So today we're looking at the same kind of problems that we were looking at yesterday. Goodness, why did all the calculus stuff print over? Okay. We're looking at the same exact kind of problems as yesterday. We're just going to go over more of these together and kind of keep getting used to this style of geometric proof. So just as a reminder to ourselves of what we learned yesterday, you always start with writing the given. So in that blank on the top, we always start with writing the given statement and the statement that you're trying to prove. Remember, that goes at the end. And we mark up the diagram. Usually you're given a diagram of some sort to work with. If you're not, you should draw one, but you'll be given one in general in this class. Mark up the diagram, do the statements and reasons, plan your argument, and then you're pretty much done once you've filled in the rest. So, as always, with this one, first we write our given. And this time we have two givens, and they're going to go in this first line together. So we have KP equals ST, PR equals TV. And then put the thing you're trying to prove where that's supposed to go. So the last step, the prove. That always goes at the end. And now we just have to fill in two more things. And when we while we're working with that, let's label our drawing so we can kind of see what's going on here. We know that KP is the same length as ST, so we mark that. We also know that PR is the same length as TV. So we mark that one with two little marks because we know these are equal, we know these are equal, but they're probably not equal to each other this way. All right. And then we're trying to show that KR, this whole thing, is equal to SV, this whole thing. So hopefully that kind of makes sense because we have one that's the same length as the other down here and another one that's the same length. So together they should still add up to be the same thing, right? Hopefully. Okay. So we have KP equals ST, PR equals TV. With step 2, they have KP plus PR. So they basically took these two and added them together on this side. Equals ST plus TV. So they took these two and added them together on this side. What does that do if you add the same thing to both sides? Yeah. Close. It has to do with addition. Yeah. This, you were going to say what? Angle. Not angle. But yeah, it does have to do with addition. This one is just the straight up addition property of equality. Because if you think of it as starting with this and then adding something that's the same to both sides, that's how that one works. It's kind of a strange one, or a strange way to look at it, because it's also sort of substitution. But that one's addition property of equality. Step 3, though, is what you were thinking. KP plus PR equals KR, ST plus TV equals SV. What does that one look like? Segment addition is that one. Yeah. Because we have KP plus PR equals the whole thing KR. ST plus TV equals the whole thing SV. So that one is segment addition. All right. And then we're done because basically what they did here was they took KP plus PR and substituted in KR. they took ST plus TV and substituted in SV right here to get KR equals SV. And so we're done. All right. Let's do another one. Let's keep getting used to these, keep working through them. Number 2. So they've already got all of the statements labeled for us in number 2. We have to fill in the reasons. What's the first reason? Given. Always. All right. If something is equal to itself, what property was that? Reflexive. Also kind of a useless step sometimes, but one you can use. All right, so from step 1 to step 3, notice we had angle 1 is equal to angle 3. We still have angle 1 and angle 3 down here, but what changed? We added, what did we add? What did we add? Down here? Angle 2, right? Yeah. What'd you say? This one's not symmetric or transitive. This one is, what is it? Addition. Yeah, it's even simpler than symmetric or transitive because we're adding the same thing, angle 2 on both sides. Anytime you add something to both sides, that's addition property. And I know it feels a little weird sometimes mixing the ones from last week, the ones from this week, but that's what we're doing. Alex.
So what's the difference between the addition postulate and the segment?
Good question. Addition postulate is when you're taking an equation and you're adding the same thing to both sides. So like if I add angle 2 to both sides here, that's regular addition. Segment addition is when you take like 2 segments and you add them together and it equals a third segment.
So like ST plus TV is equal to SV?
Yeah, like ST plus TV is equal to SV. That would be an example of segment addition versus just regular addition. Yeah, and that's one that it's really easy to get those mixed up. So that's when we want to make sure that we, keep thinking about that, keep asking questions like that. It's a good question. Okay, so in our drawing real quick, we know that angle 1 is the same as angle 3, right? And then we were also told that we've got angle 2 going on here. And we're trying to show that angle DEG, this one here, is the same as HEF, this one here. So looking at the picture, it should kind of make sense. If you add these two together, you get this one. If you add these two together, you get this one. It's kind of the same thing as proof number 1, but with angles instead of segments. It's the same idea. So with that, or it's very similar to proof 1, except with angles instead of segments. With that, in step 4, we're told angle DEG is equal to angle 1 plus angle 2. And angle HEF is equal to angle 3 plus angle 2. What am I doing there? Sean, what do you think? Angle addition is exactly it. All right, and then we got to bring this home. We've got angle 1 and angle 2 right here, and we have angle 3 and angle 2 right here. And we're told that angle 1 plus angle 2 is equal to DEG. Well, that's the same as this part right here. What if I stuck this in place of angle 1 and angle 2? And what if I stuck HEF in place of angle 3 and angle 2? We get this. What is that? It is substitution. All right. And now we've got the second one. We're going to do one more together today on the next page. So once you have this one, go ahead and turn to the next page. All right. On the next page, with this one that's labeled as number 4, try filling in what you can on this one. Go ahead and start filling in what you can. Fill in the given. Fill in what we're trying to prove at the end. Fill in what you can on this one. Fill in the given. Fill in what you're trying to prove. Right there. Fill in anything else that you think you notice. Like if you see reflexive or symmetric or something on there, fill that in. If you see angle addition or segment addition or regular addition, fill in what you know. And then we'll fill in the rest together. Hold on. In order to use this, you have to know something about it. That has to be with it. Of course. If you get stuck, look back at your list of properties and postulates and definitions and see if there's anything that matches.
The football game's at Auburn Memorial tonight, right?
Yes.
Auburn Memorial.
Yeah.
This proof is very similar to the one that we just did. And yes, the homecoming game is a homecoming memorial.
Like the Auburn football game?
Just search up Auburn Memorial on Google Maps. It's in like downtown. Not downtown Auburn, but it's in like Auburn. Up here. The football field's a piece of shit compared to that one. It's like grandstand.
And apparently we're playing it with really not good. From what I've heard, they're not a great team.
All right, guys, here we go. Come on, guys. Paying attention. Last one here. Are given. If you put measure of angle AOI equals measure of angle EOU and given, that's a good start. And then if you put measure of angle 1 equals measure of angle 3 at the end, that's a good way to end it. Now we need to fill in the middle. What does this look like? It looks like angle addition. Notice AOI is this angle right here. EOU is this angle right here. Those are the ones that we're saying are equal to start. And we're trying to end up with angle 1 equal to angle 3. So yes, this is angle addition. We've got angles 1 and 2 combining to get us this angle here. Angles 2 and 3 combining to get us this angle here. For substitution, we know that AOI is equal to EOU, right? So I'm going to substitute angle 1 plus angle 2 in for for AOI. And I'm going to substitute angle 2 plus angle 3 for EOU. Anyone get the reason for step 4? What you got? Reflexive. Yep. Something's equal to itself. And then to go from step 3 to step 5, what do I get rid of on both sides? Tavia, what do I get rid of? Yeah, we subtract angle 2 from both sides, right? To get angle 1 equals angle 3. So if I subtract angle 2, we get just this left over, and that's the subtraction property. All right. Once you have that, go ahead and turn the page. We're not going to do the bottom one, at least not today. We might do it another day. Not tomorrow. You can do it tomorrow if you want to on Saturday. You know, if you are feeling like a Saturday morning proof, you know, great way to start the day. All right, here we go. You guys' homework for tonight is these 4 proofs. They're fill in the blank, and something to know about them, we have done a proof pretty much like each of these somewhere in our packet before. So if you are stuck on any of them, it would be a good idea to go back and look through proofs that we've already done. Also, tonight I will post a video of the 3rd proof, this one. So if you would like to, if you get stuck or you want to check your work, you can see this one at some point this evening. I will post that. Okay. So you have time in class now. You got about 10 minutes. Go ahead and get started. Try to get at least one of them done. You're doing all 4 of these. So this page and this page. Ready? Go.